Okay. Now the session is being recorded.
Okay.
I can able to do that. Okay. Okay. Today we'll start with ETL concepts. Hello, Bhagesh, you're telling something?
Sorry, again?
Yeah, and for your case, like I wanted to start from data warehousing concepts, right? So that I will take it on Saturday or the weekend. And there is no dependency for
Okay, fine.
data warehouse concepts with this ETL. So first, let me start with the ETL concepts and go to Abinitio. Then on the weekend, like Saturday, I will take this data warehouse concepts for you.
Yeah, sure.
Okay, thank you. Okay, so we'll start with ETL. So the ETL, the word comes from the data warehouse and stands for extract, transform, and load. So what we are extracting and transformation and doing a loading. So here the extract steps, we are extracting the data from the multiple source systems and makes it further accessible for the processing. And the main objective of the extract step is to retrieve all the required data from all the source systems. So which all the source systems we have an agreement from the client. So from all the source systems, whatever the required data we have to extract it, all the required data has to be extracted for the further processing. And it's not just we have to do an extract. So with a minimum little resources we have to do this. So this step with a little as much as possible with the little resources we have to complete this process of this extraction step. So what I mean is, so whenever we have to extract the data from the source systems, you just extract only from one table and put it into the staging area. Then you can do a joins on our data warehouse environments once the data has been pulled. So the advantage here is we will have the data in our environment, and whenever we require we can access that. And if you are doing a joins on the source systems itself on the multiple tables, the load will falls on the source systems, which is not suggestible. And it depends upon the network bandwidth and the capacity of the source systems. But still, the suggestible is we have to get the data table to table and put it into the data warehouse environment. Once everything has been loaded into the staging area, then we can apply the transformations. So the ETL step is extracting the data from the multiple source systems, and a point is here from one table we extract from the source system and load it into the data warehouse. The reason is the network traffic load should not fall on the source systems. So as much as possible with the little amount of the resources we have to complete this extraction step. So that is what an extraction here. And coming to the data warehousing extraction step, not only we are extracting the data from the source systems, and sometimes a flat files will also be our sources like CSV files or XLS or XLSX. And we will discuss more in detail about this CSV files or XLS other than the database sources. What could be the format, some of the validation rules, what we apply, that all we will discuss it. But here I wanted to highlight not only just the databases as part of our extraction, we will be extracting the source file as well. That sometimes we call it as external sources, because the files the client from ours will be receiving from the different sources. It's not an internal to our client, it will be coming from the outside. And the transformation step what we will be discussing is, so as per the business rules we have to apply the transformation. Let's say I'm getting a one of the record value is 10. I may be directly loading to the database, that is a data warehouse, or I may be doing a transformation to make it 20. So what is that rule making it to 20? That has to be given by the client. So that is called a transformation. A value of 10 will be coming from the source. I will be applying some business rules and applying the transformation and making the 20, making the value of 10 to 20. That is called a transformation. Sometimes we don't even apply the transformation. Directly we will be loading the data into the data warehouse for some of the specific fields. It all depends and the how the client is required for this. So as part of these transformations, what all most of the things we will be doing is like generating the aggregates, generation of the surrogate keys, deriving new fields, applying the validations and joins, everything we will be doing as part of the transformation. So once we transform the data and create the load ready files, so these load ready files will be read and we will load the data into the data warehouse. And again here also, we just don't want to load the data into the data warehouse. Here also, while loading the data into the data warehouse, we have to make sure as much as possible we will be occupying the little resources. It's not just I will load the data into the data warehouse. That is not our main objective. So with the minimum little amount of the resources, we have to load it. So that how can we do it? That we will discuss as part of the data warehouse database components. But here I will give you the brief how we will be doing it. So once we load the data into the data warehouse, like before we loading into the data warehouse, we have to disable the constraints and the indexes of the tables. So once we disable the constraints and the indexes, load the dump of the data into the tables, and then you enable the constraints. So that while enabling the constraints, whatever the dump of the records we have loaded, every record it will be checked with the constraints and the indexes. So everything is fine, the load will be committed. Otherwise, the complete load will be a failure. So this is how we can make the process faster. So here the extraction step and the loading step with the minimum amount of the resources we have to do this process. So extraction is how we can do is we can extract the data from a specific table and load it into the staging area of the specific table in the data warehouse. And while loading the target table in the data warehouse, we have to disable the constraints and load the data and then enable the constraints. So these two steps we have to maintain it. So is it clear what is an ETL process? Extract, transform and load. Hello.
Yep.
Okay.
Yes, yes, right.
Okay. So now we will discuss the architecture of Ab initio. coming to the architecture of Abinitio, we will be having these components. That is, one of the tool is GDE. We call it as, that is graphical development environment. So GDE is, make a point. GDE is graphical development environment, and we will be having a cooperating system. We call it is. So this is a cooperating system. Whenever we run any of the process in the Ab initio, any process that is related to the Ab initio should run under the cooperating system. So this is like a normal operating system where the Ab initio processes will run under this cooperating system. So the GD is a front-end tool. It's a graphical development environment. This is mainly meant for developing the graphs. So in Ab initio we call it as graphs. So how do we have like mappings in Informatica on the stages into the data stage? So similarly we call it as graphs in Ab initio. So to develop these graphs we require a components. So these components are available in the GDE itself. So using these components we have different types of the components. So we will discuss it. So using all these components we will build the graph. So once we build the graph, we can test the graph, we can debug the graph within the GD itself. We can run, we can debug, we can test, everything we can do in the GD itself. So once this complete development is done related to each of the objects which we have built as part of the graph development, so those objects has to be checked into the EME. So EME is like a repository. EME means enterprise metadata environment. EME is enterprise metadata environment. So GD is graphical development and okay. So this check-in and check-out process we can do it from GDE as well as from the cooperating system. So I will come back to this again, and we have an operating system called native operating system. So in real time, the architecture of Ab initio will be, so these native operating systems will be Unix machines or like a Linux machines, or like AX, Solaris, Linux machines we have, right? So it could be one of these machines, and most of the times nowadays we were using Linux machines. So on top of this Linux operating system, we will be installing the cooperating system and GDE as well, and we will be having a technical repository. So wherever we have installed the cooperating system, from there the link will be connected to the EME. So there will be a link from the GDE to the cooperating system and a link from cooperating system to the EME. So the link between the GDE and the cooperating system will be, in the GDE we will be having a different tabs. So one of the tab is run settings we will be having. So in that settings we have to make a connection, like what is the host, what is the user ID, and what is the password, so that a connection between the GDE and the cooperating system will be established. So the connection between the GDE and the cooperating system will be, so the connection between the GDE and the cooperating system will be, in the GDE we have to go to the run settings. There a separate window will get opened. We have to enter the host, which one we are going to connect it with, the user ID, password, and then the connection between the cooperating system and EME is, we will be having a .ab initio or zip file. So here we have to represent a user ID and the encrypted password, so that a connection will be established from the cooperating system to the technical repository. And this check-in and check-out is a process like once we develop any of the objects, it will be new in our area, means in our local path. So that has to be sent to a technical repository. That process we call it as check-in. And similarly, some other developers might be developed the objects which are not in our path. So it has to be come from the EME only. So that process from the EME to our local area is called it as checkout process. So yes, GD is a front-end tool. I can do it and the right click on the project or any of the object and then do a check-in or the checkout of the process. But from the backend, that is the cooperating system or the Unix environment where the cooperating system has been installed, how can I do the same process like check-in, checkout, and many things we will be discussing it. So, but as of now, how we will be doing a check-in and a checkout process. So we have like air commands in Abinitio. That is air commands. So using air commands, we will do the check-in and checkout process from the cooperating system to the EME. Air in the sense Abinitio repository. AI is Abinitio and OR is a repository. So using air commands, we do this process, check-in and checkout process. This is what the architecture of Abinitio. So is it clear? So Ravali and
Yes,
Bhagiraj,
yes,
is
Yes,
it clear?
Venkat. Yes, Venkat.
Hello.
Hello?
yes, Venkat,
Yeah, can you
yes.
hear me?
Hello.
Yeah, Venkat, are you able to hear me?
Yeah, yeah.
Yeah,
So
it's fine. Go.
is it clear, Bhagiraj?
Yes, 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 Venkat.
Okay, okay. Ravali, is it fine for you or you have any doubts on this process?
No, Venkat, I'm fine. It's good.
Okay, fine. Yeah. Okay, let me show you how the GD looks like and then we'll go to one of the concepts. Yeah, this is the old version where, as I said, and this is a 1.1 version. Here we can get able to get to know what is the version of the GD. So this is a 1.1 version and the latest is 3.2 version and most of the projects are running on the 3.1 version only. So as I said, like the connection between the GDE to the cooperating system should go with run settings. And here the look and feel also with the new systems, you will feel the difference. This is the old one. So like this, we have to take edit and a profile file will be there. And what is the connection method we have? We are going to connect to the remote one. So here we are using only the local machine. So I have set it to local NT host. But in real time, we will be connecting with SSH connection and giving the host name, user ID, and the password and the path of the cooperating system. The options will be same, but the window, whatever we are seeing here, the look and feel will be changing. That's it. So there we will be connecting to the SSH by
Venkat,
giving the Bhagiraj.
Venkat, we used to connect with Telnet,
Oh,
but
okay.
while connecting with SSH, it will ask for some files. Do we
Okay.
need to generate those files or
Pardon?
it should be there? No, no. Actually, while trying to connect through SSH, it will ask for some files, some file paths or something.
Here you will be giving the files, you mean to say?
Yeah, it will ask for the files.
Okay.
So what are those files and how can we create those files?
Most of the cases we will go for SSH connection. I've never seen actually, frankly to say, I've never seen a telnet connection on the RegSec. So far I worked is an SSH connection.
Okay, okay, I will do one thing. I will take one screenshot of the SSH connection, how it is in my end. I
Okay.
will show you.
Yeah, that's fine.
Not be that way.
Yeah. And yeah, using these connection methods, we will connect to from the GDE to the cooperating system. And as we don't have here the connection between the cooperating system to the EME, because EME is a technical repository, we don't have that. And we will be placing all the files in the Windows environment. So whatever we have discussed here as a technical environment and placing in the Unix environment, all these files, but as part of the training purpose, we will be using this as a Windows environment. So all the files, whatever I may be creating the graph or any relating objects for the graph, will be placed under Windows operating system in the hard drive. So here I have 4 graphs like this. So all these graphs, but in real time, it will be under the Unix path. So that is the only difference we have in this. So this is how the GD looks like. Here we will be having the set of components, and here the canvas will be there. So we just drag and drop the objects, or else we can double click it, so that we can build a graph. I'll just show you the sample graph. How does it looks? So this complete we can call it as one graph with a different set of components, like data set components and the transform components. So as part of our course, we will start with the transform components. So the first component we will be discussing is a normalize. So how the normalized component looks like, I'll give you the picture. Okay. So this is how the normalized component looks like. So these we call it as ports in Abinitio. Whatever we are saying here in so this we call it as ports. This is an import and this is an output, reject, error and log ports. So a normalized component has input port, output port, reject, error and log ports. So what it will do the normalize. So normalize generates multiple output records for each input record. So if I send one record, the output of the records will be multiple output records. So it could be 2, it could be 3, it could be 5 or it could be 10. But how can we say that how many output records for each input record we can generate it? So it two ways we can specify that. One could be with the calculation and the other could be with the constant value. So if I say the constant value, let's say I have 5 input records, I am specifying a value as 3. So first input record comes and the normalized processes and generates 3 output records for the first input record. And second one comes again 3 output records. Third record input records, 3 output records. So like this, totally 5 input records and 15 output records will be there. And most of the cases we don't go for the constant value, we go with the based on the calculation. So how we do the calculation? So, and what does it mean? So for the first input record, I may be requiring 2 output records, and second input record we may be requiring 5 output, and third one we may be requiring again 3 input records, 3 output records, sorry. So it all depends on the calculation of the input record. The output record should be decided. Yes, most of the cases we go by the calculation. And in normalize we have two types of the transformations. One is simple transform and the other one is multi-stage transform. Let me open this normalize example. Okay, so this is how the normalized component looks. Input port, output port, reject, error and log ports. So here before going for the simple transformation, I just wanted to brief explain about this ports. So port will say that what kind of the structure of the data we are getting it to each of the component. So here also this is one kind of the component. Here we will be having a read port. So this also I will just show you, and before going that I will just go it in the path of this file. So see Abinitio examples. Input.dat. So yes, this is the file we are reading in this. So if I ask you like what is the structure of this file, can you able to tell? So what is the first field and what is the value of the second field, third field, and how many fields we have and how many records we have it? No, I cannot tell because I'm unable to read this file. I can able to see the data, how does it looks, but how many records we have, how many fields we have, no, I have no idea of this. So similarly, if I just specify only the file, none of the components will recognize it, what kind of the data we are getting it. So at the same time, along with the file or the data we are getting to the component, we have to specify the record format, that we call it as the structure of the file. So the structure of the file in the Abinitio, we call it as record formats and save it with .dmls. Make a note of this point. The structure of the file will be represented as a record format in Abinitio and saved as .dmls. Let me look at the structure of this file. Yes, now I can able to understand. Yes, the first field is a string of 7 bytes of customer ID, the field name is, and the second field is decimal of 2 bytes and it says number of transactions, and the third field is a record format and the name is transactions, that is a vector this is, and of the size is n-trans. Again, what is the field we have it, the value of that field will be the size of my vector. So what is a vector again? So in any of the programming languages, if you want to define a variable, so we will be defining with that what is the type of the data type, let's say int a. So now a has a provision to hold the values like 1 or 2 or 1 2 3 like this. If I send a value like abc, does a variable a will hold abc? No, it cannot, because the variable a is defined of type integer. And similarly, if I define a variable of type string, So this variable can hold a type string data type. So I can pass it A, I can pass it ABC, and I can pass it even 1, 2, 3 also. So 1, 2, 3 is a decimal, and that we are making it to string by defining in the codes. So now the B can able to store the values, all these values. So now if I have a requirement to hold into one of the variable int, I defined A. So in this I can save, let's see, the size I can give you as 10 array size. So here I can able to store 1, 2, 3, 4, 1, 2, 3, any numbers till 10 digits. But if I wanted to store still A, here I cannot do that, because array says each and every element of the value within the array should be of same type. So if I have a requirement to store like 1 comma A as one of the value, then we have to go for user defined functions, user defined data types. So we have to create type name equal to record, and then int A string B and end. So now we have created our own user defined type. So whatever the type name we wanted to give, that we can give it, and create a variable of that type name. So type name and a variable. So now this variable has a provision to store a value of type integer and a value of string like this 1 comma A. Still I am not fine. So I wanted to save the values of 1 comma A, then 2 comma B, and 3 comma C, and so on. All these values I need to save it. Then we have to create a record type like this, our own data type, and it should be of type array, and we can make it integer. Now this variable have a provision to store all these kinds of the values, so that we call it as a vector. So like this, a transactions is a vector variable and the size is of n-trans. So whatever the value we have in this n-trans, that is the size of these transactions. So let's go back to view the data in this file. Now we can able to understand what kind of the data this file contains. Okay, yeah, now it, whatever the file I have shown in the Windows, same file we have read it using a record structure. So this is how the record format is available. The customer ID and number of transactions done by this customer is 2 transactions. So in the transactions is a vector which should say 2 transactions with the transaction date and the amount. So the transactions is a vector, and the first element of this vector is a trans date and the amount, and the second element is also a trans date and the amount with this proper values. If the customer has made 3 transactions, the vector size should be 3, and here only 1 transaction, so the vector size is only 1. So 2 transactions, again the vector size is 2. So this is called a vectors. So now for each of the input record, I have to split the records into multiple records. So here, how am I splitting the records, and how the what are the tabs we have in the normalize we will discuss. So whatever the structure we have seen, the same structure of the data is flowing from this flows to the normalized component from the input. So the input, the record format should be equivalent to the file record format. So let's see. So whenever we wanted to see the record format, then we have to traverse to the ports tab. Now click on the port which you wanted to look at the record format. So now we have selected input record format to view and just click edit. Yes, so if you can look at the same one which I have shown on the input file component. So the same record format, whatever the input file is sending on the flow to the normalize, the input port of the record format should read the same one. So this port is reading the same data, whatever it is, this component is flowing to the normalize through the input port. So once the data comes to the input port, from the input port to the normalize, then from the parameters tab, we have a parameter called transform. So in Abinitio, whatever the transform we write it will be saved under as .xf4. Make a note of this. One we discussed is a DML, the other one is xf4. So the record format or the structure of the file will be saved as DML and will contain under ports tab. The record format or the structure of the file will be saved as .dml and will reside under ports tab. And the transformation will be saved as .xf4 and will reside under parameters tab in transform parameter. So this is the transformation we have written and saved as .xf4. Let's look at the transformation. We have two functions here, the length and the normalize function. Now we were discussing a simple transform. So in simple transform, we have to write two functions, that is length and the normalize function. So length will take input as an argument. Okay. So this is the input data we are getting from the component input file to the normalize from the import. So first this record will be traversing. This input file component has a file which has 4 records. So the first time whatever the highlighted record will be, the first record will be going to the normalize from the input port. So once it reads, the transformation will get executed. So this is a simple transform. Here we have defined two functions, length and the normalize. So the length takes input as an argument. When I say in as an argument, so whatever we have highlighted, the complete record format or the record will be accessed here. So here I wanted to identify the length of this record. So I wanted to know the size of the vector. So I have used length underscore of. This is a predefined function which takes input as a vector and returns the size of the vector. So here indoor transactions is a vector field. So this field I am taking it. Means this complete field I am taking it. So this complete record will go to the normalize and I am just accessing indoor transactions. So then whatever I have selected, this record will be going to this indoor transactions. So this value will be, that vector value will be taken as an argument by the length of function and returns the size of the vector. That is, it has two elements, the 0th element and the first element. So the length of returns the size as a 2 to the length. So once it has written the length as a 2, the normalize function will get executed. And here we have two arguments, the normalize in and index as an argument. And by default, the index starts with 0 and the condition should be, and the normalize runs keep on looping. So how many times the normalize function should run? The condition here is the index value should be less than the length. So the length has returned 2 for the first record and the index starts with 0. So 0 less than 2, condition true. So it comes inside, and in dot customer ID is assigning to the out dot customer ID. So this is how the assignment operator will be there. So whenever we wanted to assign to the output fields or output, then we have to use this colon colon. So here in dot customer ID is C002142, and we are assigning to the output. So we are assigning to the output in the sense, here we are assigning to the output port. Let's see the record format of the output port. So here we have three fields: customer ID, translate, and the amount field. And a new line always says that whenever we press an enter key, that /n character should hold it. So that is the reason we are using a string of 1 of new line character. And expecting that we have three fields: customer ID, translate, and amount on the output record format. So all those three fields we have to assign it. But how are we getting the values is, in dot customer ID we are getting the value C002142 and assigning to out dot customer ID. And similarly in dot transactions is a vector, so I want to access trans date. So here we have two records, means two elements particular to the trans date, but the index at the current point is 0. So whenever I say in dot transactions, the cursor will come to the current record here, and then we are accessing particular to the index. Now the index value is 0, so now the cursor was at this position. Whenever we call it with the index, the cursor will come to the 0th element, because currently the index is 0. And now we can able to access this complete record, that is record element 0, translate, and the amount. But we are accessing dot translate. So now the cursor was at record position, the control will come to the translate and pick.
Venkat, your voice is breaking.
My voice is breaking. Is it clear now?
Yes, it was.
Okay. So
Yeah, now I can hear.
okay. So whenever I say indoor transactions, the cursor will come here, and particular to that index, the index value currently is 0. So it will come to this element of 0th element. And here we can access two fields, translate and amount, but we are accessing indoor transactions of index dot transdate, means the cursor will come to the transdate field and pick the value, that is 1994.03.23, and assign it to the outdoor transdate. And similarly indoor transactions of index 0 dot amount, indoor transactions, the cursor will be here. Again the index 0 comes to the record, that is the 0th element, and then we are accessing the amount field. So 52.20, get the value and assign it to the amount field. Now the control comes to the end. So we have completed for index 0. So the condition here is index should be less than the value of the length. Those many times the normalize function will be on loop. So then the control again comes to the normalize, increments the index by 1. Now the value of the index is becomes 1. 1 less than 2, as the condition is true, again comes inside the in dot customer IDs. Still we are at the same record. So C002142 and assign it to out dot customer ID, and then in dot transactions of index. Now again comes to the cursor here. Of now the index is 1. So directly the cursor will come to the record, this record. And similarly we were accessing translate of the first element. So 1994.06.22, and get the value and assign it to out dot translate. And similarly indoor transactions of index dot amount, that is the first element of the amount, that is 22.25, will get assigned to the amount field. Uh, excuse me. So again the once the control comes to the end, again goes back to the normalize, increments the index. So now the index become 2. So 2 is less than 2, no, the condition false. So once the condition false, comes out of the normalize and goes to the length by reading the next input record. Now the next input record, right, and the length function will get executed again. So now again the indoor transactions has three elements. So the length of function will take indoor transactions as an argument, that is a vector, and returns the size of the vector. So 3 will be written now. This length function for the second input record returns 3. Again, index starts with 0. So in this case, the possibilities are 0 less than 3, 1 less than 3, 2 less than 3. When the index increments by 1 again, it will become 3 less than 3, condition false, and comes out of the normalize for the second input record. So like this, for all the records, the length function will get executed once, returns the size of the vector or how many records we are expecting the output. So finally this is returns the size, and those many times the normalize function will be looping it and returns the vector to the serial. So most of the cases we will get a vector data to the normalize and expecting the output to be in the serial. So in this case, first input record 2 records, second input record 3 records, third one 1, and fourth one 2 records. So totally 2 plus 3 5 plus 1 6 plus 2 8 records will be the output for us. So let me run the graph. So this is the button, or the you can press F5 button to run the graph. So here itself we can run it. So whenever the graph is running, you can able to see in the green color. Once it completes successfully, it will be ended with the blue color. Otherwise, if it fails, it show in the red color. So let's view the output file. Okay, we quoted 8 records. So C002142, 2 records with trans state and the amount field. 3213, 3 records because the size of the vector is 3, and 4221 is only one vector of size 1, and 8231 is vector size 2, so 2 records. So the vector data has been split into the serial data. So whenever your requirement is like vector to the serial, or one record has to be split to multiple output records, then you have to use a normalize. So is this clear?
Yes, Venkat. And Venkat, if you want to use normalization, so the data should be in vector format, right?
That's not
Or
a
else,
mandatory actually, but most of the cases in the real time we will get a vector data and we will split into serial, but that's not mandatory. Even though if we are getting a serial data and expecting it into multiple records due to the business requirement, yes, that is also possible.
okay.
But there are chances of only 1% for that cases, serial to serial with multiple output records.
Okay.
So is
So
it
do
clear
I have
enough
any
for you?
examples for that? Yeah, it's clear.
Okay, and Ravali, for you?
I'm good, Venkat.
Okay, fine. Yeah. Okay, today we will stop it here, and before stopping that, I will just at a glance I will tell you what all we discussed. We have seen what is an ETL and the architecture of Abinitio, and then we come into the transform components of the normalize. And here the highlight things are what is a ports we will contain in the normalize, input ports, this we call it as input ports, output port, reject error under the log ports, and within the normalize, the ports tab has a record format or the structure of the DML, and it will be saved as .dmls, and the transformations will contain in the parameters tab under the transform parameter and saved as .xf4. So as of now, these points has to be remembered: ports, DML, and the xf4. And in simple transform, we will call two functions, length and the normalize. And tomorrow we will see multi-stage transform with many other examples, like many other functions. Here we have only two functions, so we will see the difference between the simple transform and the multi-stage transform in the tomorrow's class. Is it fine?
Yeah.
Yeah.
So simple transform will always have only two functions?
Yes, yeah, length and the normalize. So if your requirement is just getting the vector data, or it's like not mean to say vector data, one record has to split it to multiple records. Just you have to split it without any calculations, anything. So most better example is like vector data. That is the reason we take vector data. So one input record and multiple output records without doing any calculations within that. So then we have to go for simple transform. And if you want to define any
So vector data,
yeah,
so vector data, you will see it, or I mean, you can view it only when you import the file in an Ab initio. Because earlier you were showing that in Windows the text file was like, it's the regular text file, right?
yes, it's a regular text file. So the reason I've shown you is just to explain the structure of the file, that is a record format. Because even though like for this component, if I just give like a dat file, whatever I've shown in the Windows, this file cannot understand. And not only this component, any component here in the normalize also, without defining the ports, if I just tell you to this component that this is what the data you are getting it, how we are understood, we don't understand. So similar that the component will not understand. So just to explain that, I have shown the file before going for the record format. So this is the records we have it. So I cannot understand what is the at least I don't know that we have a vectors in this file till we go read the data.
Yeah, okay.
So just to explain the
And
concept,
Venkat,
yeah.
And you're using the
uh,
same CAD file in your Ab initio, and when you see the input file, it will be like, I mean, it will have all the vector data and all
Yes,
those things.
yeah. So for that we have to specify the record format or the structure of the file. Then only if I can view the data, it will give it. If I don't specify the record format, even the component will not understand what is the structure of the file.
Okay. Can Ab initio also take XML files?
Yes, it will take it.
Okay.
Yeah, but you were asking something.
yeah, means you haven't mentioned any delimiter here. So if you haven't mentioned any delimiter, it will
Leave
default
that,
take space or
the lead. It's a fixed size GML.
okay. Means in this case, the delimiter is space.
No, it will not be the space. It will be a fixed size. Till first 7 bytes, it will be considered as a customer ID. Next 2 bytes will be
Okay.
considered as a transactions in trans. And then it will store
Mm-hmm.
a record, that is a vector. And whatever the size of
Okay.
this entrance, those many bytes, it will take it. And in real time,
Okay. Fine.
even as part of this training purpose, I will be showing with the comma delimiter. But in real time, we will be having like /x00 like that delimiters.
Okay.
It's not like specific to the project. I don't say all the projects this is the delimiter. It's specific to the projects and the
Okay.
fact they are getting it. So
Okay.
here, right, simple transform with the normalize.
Mm.
Yeah, okay, then we will stop it here for today, and tomorrow we will discuss with multi-stage transform.
Yeah. Okay.
Yeah, thank
Okay.
you.
Thanks, Venkat.
Yeah,
Thanks a lot.
Thank you.
yeah, thank you.